Hello, today we will discuss fat storage and breakdown and the processes by which they occur. We will start by looking at the process of a pluripotential stem cell moving into an adipose cell. First, we know that the entire process cannot occur without cortisol and insulin, as these promote the storage of fat. Next, we'll consider lipogenesis, which is the actual process of storing fatty acids into a pre-adipocyte or an adipocyte cell. Lipogenesis is regulated by lipoprotein lipase, which we will discuss more on the next slide. There are also several antipolytic and adrenergic receptors which promote the storage of fatty acids into adipocytes and the creation of new preadipocytes. It is worth noting that once an adipose cell is created, fatty acids will be continued to added to it until it reaches its maximum size. Although the size of adipose cells may shrink, the number of adipose cells will not. And once an adipose cell reaches its max size, a new preadipocyte cell will be filled with fatty acids. On the other side of fat storage, there's also fat breakdown into fatty acids. This process is called lipolysis, and it provides energy to the body. Hormone-sensitive lipase regulates lipolysis. There are also several lipolytic and adrenergic receptors that promote this breakdown of fatty acids into adipose cells. Lipoprotein lipase is responsible for breaking down triglycerides found in the bloodstream so that fatty acids can be stored in adipose cells. As levels of lipoprotein lipase increase, fat storage also increases. After we eat, lipoprotein lipase increases as the fat in our meal is absorbed and stored into adipocytes. Levels also increase when there are higher levels of insulin or after exercise as the body tries to maintain homeostasis of fat levels. Although lipoprotein lipase initially decreases when we diet or fast, after several weeks or months of this, lipoprotein will increase as the body again tries to maintain homeostasis in our fat levels. This is problematic for dieters, because once the diet or fast is over, they are then stuck with elevated lipoprotein levels, which increase the amount of fat storage when they go back to their regular eating pattern. This is one reason why it is difficult to keep the weight off when it is lost through a diet. As we know from looking around, women tend to store more fat in their gluteofemoral region, while men tend to store more fat in their abdominal region. One reason for this is that lipoprotein lipase is more abundant in the gluteofemoral region in women and in the abdomen region for men. As lipoprotein lipase levels decrease, fat storage also decreases. As discussed, this occurs initially when dieting or fasting, and it may also occur in response to insulin resistance, which is one reason why diabetics may have higher levels of triglycerides in their bloodstream. Leptin is a protein produced and secreted by adipose cells to signal satiety to the brain. When the brain receives leptin, it then triggers anorexigenic peptides to induce the feeling of satiety, and thus the slowing and stopping of eating occurs. Therefore, as leptin levels decrease, eating increases. This happens when we have not eaten for some time as a result of diet or fasting, or as a result from weight loss. Alternatively, as leptin increases, eating decreases. This happens once we have eaten enough and signals satiety. And as you can see, if there is an issue with leptin levels or leptin receptors, then satiety may not be signaled appropriately and overeating may occur. This, however, is not typically the case seen in obese individuals. However, leptin resistance does occur with insulin resistance and thus results in weight gain in some diabetics. Thank you for your time.